Okay, we're going to take a look at some more nomenclature. We have our organic compound right here. So the first thing is we have to see if there's any functional groups. We have this one right here, a hydroxyl, very clear, that gives alcohol properties to the whole molecule. So we're going to make the systematic name of this, and we're going to do it step by step. The rules are going to change a little bit from the alkanes nomenclature, but not so much. So let's take a look at it. We said the first step was going to be box the longest chain of carbons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I like this one. Now, the rule is going to change a little bit because in our first rule, instead of just boxing the longest chain of carbon, the rule is going to be box the longest chain of carbon containing the functional group in it. So I am going to box the longest chain of carbon that has the OH in it, and that's the one. Now, the second step is numbering it. We said to name alkanes, we are going to number it, giving the substituents the lowest possible number. In this one, the rule is going to change too. The priority is going to be on the functional group. So we're going to give the functional group the lowest priority possible, the highest priority possible. So if we start from here up, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. No, the hydroxyl group is going to be on carbon 8. If we start from here, then it's going to be 1, 2, 3. And that's what we want. We want the hydroxyl in the lowest possible number. I am missing a hydrogen here. So I'm going to start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now that I have that, I can name the parent chain. The way I'm going to name the parent chain is going to be, I say where the hydroxyl is, so 3. And remember, between numbers and letters, you use a dash. Between letters and numbers, you use a dash. So my chain, my parent chain is hexane, decane, 10. So I'm going to write dec. There's only single bonds, so it's going to be a. And then I have the 3, so it's going to be all. The all ending refers to the OH. It means that there's a hydroxyl group. So I have my parent chain. So whatever is left is the substituent. So I have one substituent right here, and I have another substituent right here. So the name of this substituent is ethyl. And I have to say where it is. This is carbon 7. So I'm going to write 7-ethyl. And this is 5 in carbon 5. And that is an isobutyl. So now I have the 3 names, and I have named everything. So now I'm going to place everything in the order that we're supposed to put it. So we have to remember, first we start with the substituents, and last we go to the parent chain. So I am going to start with ethyl. It goes before isobutyl. So I'm going to say 7-ethyl dash, because I'm going to a number, 5-isobutyl dash 3-decanol. Okay, we're going to do some more nomenclature of alcohols. So we have this structure. It does look pretty scary, so we're going to try to break it down into pieces to make it more accessible. Like I said, we got to look for the functional group. We have this one and we have this one. This one is a double bond. It makes it an alkene. And this one is our hydroxyl. It makes it an alcohol. So first rule again is we're going to box the longest chain of carbons containing the functional groups. So I am going to pick this one, all of this. There you go. So that's my parent chain. Now I gotta count, and to count we're going to start from the side, either one of the ends, to give the functional group the lowest possible number. So if I start from here, it's obvious that it's going to be a ridiculous number. If I start from here though, it's going to be 1, 2, 3, 4. So I'm going to start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that is my parent chain. I know it's an alcohol and it has alkene properties. So whatever else is left, we know it's going to be substituents. So we have 3 substituents here. These two are the same. We have a methyl here and a methyl here. So we know they're the same. So I'm going to go ahead and name them. It's going to be 3, 8, dimethyl. There's 2, dimethyl. And then I have in 6 an ethyl. There's a carbon here and a carbon here. So 6 ethyl. Now my parent chain. The way I'm going to name this is, I know there's 10, so I'm going to say dec. Now, in carbon 7, there is a double bond, so I have to name that. So I'm going to say dec 7 in, right there I just said 10 carbons. In carbon number 7 dash, I have a double bond, but it doesn't end there. I have to say in carbon number 4, there is an ol. So that's the name. There is dec 10, in carbon 7, double bond and in carbon number 4, there is an alcohol group. So I put them together. We have to remember that this is the substituents are going to go alphabetical order. We do not use the di. We start with M. So it's going to be 6 ethyl dash 3, 8 dimethyl. Dec 7 in 4 ol. Okay, one more example for alcohols. We have this structure, and scanning it, we can see that we have a double bond here as functional groups. We have a hydroxyl and another hydroxyl. So we said first step is to box the longest chain of carbons. So I'm liking this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to box it. There. It does contain the functional groups, so I'm good. I'm on the safe side. Now, the second step was numbering it. And so I have the option to start from here, or I have the option to start from here. So if I start from here, I get my functional group 1, 2, 3, 4. if I start from here, I get my main functional group 1, 2, 3. So I will start from this one because it gives the functional group lower priority. So I will say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to give the parent chain a name. We are going to say it has 10, so that's deck. And then we say in carbon 1, between carbon 1 and 2, it has a double bond. So we are going to name only the first carbon, which is 1. So we say deck 1 in, that means in carbon 1 there is a double bond, and then in 3 and 7, 3, 7, we have 2 di alcohols. So it might look complicated, but if we pay attention, the only thing we're saying is we have 10 carbon chain. In carbon number 1, we have a double bond. In carbon 3 and 7, there is 2 alcohol groups. So then we can assume that whatever is left are substituents. We have this one, we have this one, and this one. So I try to do different shapes. I guess this doesn't look different as that, but it's like a triangle looking kind of thing. So this one is the same as that one, so let's name it. I'm going to say in carbon 5, in carbon 7, there is dimethyl, 2 methyls. And this one, I'm going to name it carbon 5, the chain. There is an iso butyl group. So we have all the names. Now we have to put them together. We know that the substituents go first, so this one and this one. And we do not take into account the di. That just means 2, but it's the same group, methyl. We do have to take in consideration the iso, because isobutyl is not the same as tert-butyl or N-butyl. So we do take in consideration isobutyl. So we say I versus M. And I goes first. So my name will start with 5 isobutyl dash 5,7 dimethyl, and then the parent chain dec 1 in 3, 7 diol. And that's the IUPAC name for this structure.